Hi grade 11. So today we're doing lessons 6.1 and 6.2 together, and there's a handout on Teams that you should fill in as you watch this video. So at the top of the handout there in the box it says, while some situations are best modeled with linear relations, for example the cost of dinner versus the number of guests, so that would be just a linear relation, and some with quadratic relations, for example the height of a ball versus time, others are best modeled using periodic functions since they involve repetitive patterns. For example, heartbeat, breathing rate, cycle of the moon, position of the earth from the sun throughout a year. So that might look something like up, down, up, down, up, down, up, down, up, down, right, for your heart rate. So that repeat. So let's fill in some of these terms here. So what is a periodic function? A periodic function is a function whose graph repeats at regular intervals. A cycle is the shortest distance on a curve before the curve begins to repeat itself. A period is the length of one cycle. Axis of the curve is the horizontal line halfway between the max and min y values. And the amplitude is the distance from the axis of the curve to the max or min value on the curve. So A for amplitude equals the max value minus the min value divided by 2, and that will be the amplitude. All right, so we have this chart and we have these four functions, and we're going to fill in the chart using these four functions. So we're going to look at the cycle, the period, the equation of the axis, and the amplitude. Okay, so for function 1, what we need to ask, what is the cycle? So remember that the cycle is the shortest distance on a curve before the curve begins to repeat itself. So for function number 1, I start up here at 1, I go down, okay, now I'm back at 1 and I'm going to start repeating again. So the cycle goes from -1 to 0. Now, the period is the length of one cycle. So from -1 to 0, that's 1 unit. So the period is 1. The equation of the axis is where it's the horizontal line halfway between the max and the minimum y values. So my maximum y value is 1. My minimum is -1. So halfway between that is 0. So the equation of the axis is the line y equals 0. And then the amplitude is the maximum value minus the minimum value divided by 2. So 1 minus negative 1 divided by 2 is 2 over 2 equals 1. All right, let's do it for the second one. So I need to first find the cycle. So starting at negative 1, go up, down. Okay, now I'm going to start again. So it's from negative 1 to 0 again. That's 1 unit, so the period is 1. The equation of the axis, my max value is 1. My min value is 0. Halfway between 0 and 1 is a half. So my equation of the axis is y equals 0.5. And then my amplitude is the max value, 1, minus the min value, 0, 1 minus 0, divided by 2, equals 1/2, or 0.5. All right, for the third one, we start at 0, go up, down, and back to 0. Now we're going to repeat again. So that was from negative 1 to 0. And that is 1 unit. The equation of the axis, max value 1, min value negative 1. Halfway between is 0. And then the amplitude would be 1 minus negative 1 divided by 2 is 2 over 2 is 1. And the last one, I start at 0, I go up, back to 0, and then I'll repeat again. So my cycle is from negative 1 to 0. So that's 1 unit. So the period is 1. My max value is 1. My min value is negative 1. So halfway between that would be 0. So my equation of the axis is y equals 0. And my amplitude is 1 minus negative 1 divided by 2. Is 2 over 2 is 1. Hopefully that helps to explain those terms a little bit. All right, now that basically sums up 6.1. So 6.2 is investigating the properties of sinusoidal functions. So sinusoidal functions are functions using like the sine curves. So sine, cos, and tan. We're just going to talk about sine and cos today. So we're going to start by filling in this chart, and then I'm going to show you how to graph them. So f of theta, or f of x, we could say, right? It's theta is just an angle measurement like x. So we're using theta in this case. F of theta equals sine theta. So the period for sine theta is 360 degrees. So instead of being like 1 now, it's a degree measurement. And the period, that's the period. The amplitude is 1. The domain, theta, is a member of the real, so x is anything. The range is negative 1 to positive 1. So our minimum value is negative 1, and our maximum value is 1 on the y-axis. And the zeros are theta equals, back in the negatives, and then 0, 180, 360. For cos, our period is also 360 degrees. Our amplitude is also 1. Our domain is the same. Our range is the same. Y is between negative 1 and 1. So again, that's minimum and maximum. But now our zeros are different. So theta is 90, 270, 450, and so on. So we're just going to graph one period of each of these. I'll give you the definitions of these for a second. So the sine curve, it represents the vertical distance of a point from the x-axis as it rotates theta degrees about a circle with radius 1. Just if you're wondering where we're getting these numbers from, that's where. And then the cos curve represents the horizontal distance now instead of vertical. Of a point from the y-axis as it rotates theta degrees about a circle with radius 1. Okay. So for the sine curve, using the chart above, we need to go up to +1 and down to -1. So this is y, and this is x. Our zeros occur at 0, 180, 360. So we're going to, every 4 squares is going to be 90 degrees. So just label the bigger ones so that it's not a mess. Right, so 90, 180, 270, and 360. Okay, so the sine curve starts at 0 because our first 0 is 0. Our other zeros are 180 and 360. Now, halfway between 0 and 180, the curve reaches 1. And halfway between 180 and 360, the curve reaches -1. Okay, so the sine curve starts at 0 and goes up. Now, we're going to connect these dots with a smooth curve. There, and that's one cycle of the sine curve. Now, you could graph this using a table of values if you weren't sure, but eventually you'll memorize this. But for example, so this is 45 degrees here, right? This point here, if I type sine 45 into my calculator, that equals 0.71, which is that point there. Sine 90 on my calculator equals 1. Sine 180 equals 0. Sine 210, sine 225 equals -0.71 right here. Okay, so these numbers are all coming from the values of sine. It forms a curve. Okay, now the graph of cos, we start at 1 and then we go down. Whereas up here we started at 0. So same thing here, up to +1, down to -1. And then we'll label the same degree measurements. Okay, so we're going to start up at 1. Our zeros are 90, 270, and 450. So halfway between 90 and 270, we hit -1. That's 180. And then at 360, we're back up to 1 again. Now we're going to connect these with a smooth curve. And that is the cos curve. Okay, so I'm just going to do a question with you from the textbook, just so that you know how to apply this. So this is page 355, number 9. So number 9 says, sketch the graph of a periodic function with a period of 20, an amplitude of 6, and whose equation of the axis is y equals 7. So amplitude equals 6, period equals 20, and equation of the axis is y equals 7. So the period is 20, which means it repeats itself every 20 units. So I'm going to do 5, 10, 15, 20. The amplitude is 6, so that means from the axis to the top, or the axis to the bottom, is 6 units. The axis is at y equals 7. So I'm going to go 5, 10, 15. So this here is 7, and that's my axis. Now, I have to go 6 units up from the axis and 6 units down. So I'm going to start at 1, which is 6 units below the axis, and then I'm going to end at 1 as well, because then that's when my cycle would be repeating, right? Halfway between those points, I'll hit the max, which would be 6 units above 7, which is 13. And then halfway between 10 and 0, I would hit the axis. And halfway between 10 and 20, I would also hit the axis. So now I'm going to connect those lines using a smooth curve. And that is now graphed. So this question didn't clarify if we needed to start high or start low. So your graph could look different. You could start up here at 13 and go down, and then it would look like that, and that would also be correct given this information. All right? Okay, so today you actually need to do the homework as well. You don't get a separate day for it just because, just to get us to June 5. We need to do 1 day of overlapped homework, so that would be today, and just let me know if you have any questions. There's only homework from 6.1, so it's not like there's homework from both, but I can help you if you have any questions, so just let me know.